In this video, we're going to be talking about multiplying and dividing variables and what we do with the exponents in those cases. So this is a skill that is something that I can almost guarantee you are going to see in some application on the ACT. So let's make sure it's a skill that's not that challenging. You've probably been doing this since early on, 7th, 8th grade, pre-algebra classes, algebra classes, and it's a skill that you're probably using and you don't even realize it. But it's always a good idea to review this kind of skill, because sometimes when we run across a question, sometimes we begin second guessing ourselves. So let's get it handled here and know this is a question you will be able to answer correctly. You can only multiply and divide variables if the variables are the same. You may have heard the wording, they have to be the same bases. That's what we're talking about here. So we can only do this kind of operation if we're talking about the same type of variables. So for example, if you have a times a, we know we can multiply that and simplify it to a squared. But if you have a times b, all we can come up with is ab. A times b is equal to ab. We cannot simplify that any further. Same thing with division. If we had x cubed divided by x, we can simplify that to x squared. But x cubed divided by y, that's as simplified as far as we can go. So we can only do these things with the exponents when we have the same base. So what about multiplying variables? We did that in our examples. What exactly were we doing? When we have the same base and we're multiplying those variables, we add the exponents. So in this first example, we have y cubed times y to the fourth. We have the same base of y, so then we can just take 3 plus 4 and we're going to end up with y to the 7th. We add the exponents. Even if we have a negative exponent, same base of b, we'll take 5 plus a negative 3, which really just comes out to 5 minus 3, and we are subtracting here because the 3 is a negative, so we get 5 minus 3, b squared. But we're still adding the exponents. That's the overall operation there. Now, with dividing variables, again, with the same bases, we can divide by subtracting the exponents. So if we have y to the fifth divided by y squared, same base of y, so then we can take 5 minus 2, and we end up with y cubed. What about if we have a larger number in the denominator? It turns out to be like this. We can set it up, same base of a, so we subtract, because we're dividing, 2 minus 6 gives us an a to the negative 4. Now, if that's one of your answer choices, you would pick a to the negative 4, but a lot of times if you're working a math problem, your teacher may even say, write the answer with positive exponents. So in this case, what do we do with that negative 4? Well, that's where we're going to address it right here. If your exponent is negative, to make it a positive, we're going to use the reciprocal. So a to the negative 4 is the same as 1 over a to the fourth. Same way, what if you have a fraction like 1 over b to the negative 3? If we want to make a positive exponent, we're going to take the reciprocal of that and just have b to the third. So remember, to make an exponent positive, you get the reciprocal. We'll flip it. So that's how we handle multiplying and dividing with exponents. The other operation that you may see is when we have variables with exponents that are raised to exponents. So what we mean here, x squared times y in this example, that term, x squared y, everything inside the parentheses is squared. We're squaring that, taking it to the second power. You can also think of that as like multiplying 2x squared y. So you have x squared y times x squared y. That's what it is. But as we are raising to higher powers, it's a little bit more challenging to write out each term that many times. So we know, though, when we are just multiplying, we can multiply variables that have the same base. We can multiply and handle their exponents by adding the exponents. So for x squared y, I'm going to group my x's, group my y's, so I'll multiply the x's together, x squares together, and I get x to the 2 plus 2. My y's together, which are 1 and 1, When I add those exponents, I come out with x to the fourth times y squared. So again, we have the issue if our exponent gets really big, it's harder to do that and multiply those all out. So in general, all we have to do is we multiply each of the exponents within the parentheses by the power that we're raised to. So in this case, with the a to the fourth b squared, we're going to multiply the 4 times 3 and giving us a to the 12th, and the 2 times 3 on the b, giving us b to the 6th. So we have a final answer of this one, a to the 12th, b to the 6th. Let's take a look at an ACT type example. Pause the video and try this problem. So we're asked which of the following is equivalent to, in parentheses, 2x to the third, y to the fourth, all of that raised to the third power. So we're going to raise each term in the parentheses to the third power. That means 2 to the third, don't forget that 2, x to the third is going to be raised to the third, and y to the fourth raised to the third. So first handle the 2, 2 cubed is 8. Then we'll multiply the 3 times 3, giving us x to the 9th, and the 4 times 3, giving us y to the 12th. And that gives us the final answer of B. Don't forget, don't leave out cubing that 2. That is a common mistake people make. And then just remember what we do when we raise a variable to an exponent, we multiply. When we're multiplying variables, we add their exponents, and when we divide variables, we subtract their exponents.